Our last video in the chunk about measurements. So we're going to be talking about mass, volume, and density. Okay, so our first little review here is, remember that mass, a vocab term here, mass is the amount of matter, or we can think of it as the amount of stuff, matter is stuff, or particles, an object is made of. And remember, we measure it using a balance and base units. So the unit that goes behind the prefix, our base unit, is grams. And just a little visual for you that a gram is roughly the mass of one paper clip. Kilogram, okay, that's one of the more common prefixes used with grams. A kilogram would be used to measure your mass. So if you were going to actually step on a scale and find your mass, kilogram would be your unit. Okay, so an example of mass in a particle diagram would be here. And you can see that A has 1, 2, 3, 4, 5, 6 particles. B has only 3 particles. So you could think of A's mass as being 6. Whoop, hold on. Well, B's mass you could think of as being 3. So you would say that A has a greater mass than B because it has more particles. All right, next term that we talked about in this last chunk of the unit here is volume. And volume, remember, is the amount of space that something takes up. Okay, and there's 2 different ways to measure volume, and it depends on if you're talking about a liquid or if you're talking about a solid. Okay, so first of all, with a liquid you would measure using a graduated cylinder, like water, for example. The base unit for volume is the liter. And if you're trying to think about how big of a liter is, think about a 2-liter bottle of soda. So a 2-liter bottle of soda would be, of course, 2 liters. Graduated cylinders that we use in class normally would measure in milliliters. And if you're trying to visualize a milliliter, think about it this way. There are about 20 drops of water in every 1 milliliter. So 1 milliliter is about 20 drops of water. If you're measuring the volume of a solid, that's a little bit different. We did this in lab. Okay, if it's a regular object like a block, you're going to measure the length, the width, and the height, and of course you measure it in centimeters. And then all you do is multiply length times width times height, and you get the volume. And the unit you would use would be centimeters cubed. Now remember that a centimeter cubed is exactly equal to a milliliter. Okay, they are exactly the same size. So that makes it easy. If you are measuring a solid, you can compare it to the milliliters of a liquid. In our example down here, you can have a particle diagram example, A versus B. You see that A has 3 particles, B also has 3 particles. However, you see that B takes up more space, so B would have the greater volume, even though they have the same number of particles. All right, so then the next thing we did was we looked at the relationship between mass and volume. And this was our lab that we did where we measured mass and volume of 3 different objects. We plotted a graph of mass versus volume. Mass on the y-axis. Volume is, of course, on the x. And what we found was the domino was the steepest, the water was in the middle, and the wood was the least steep. And we were looking at those couple of relationships. A couple of things that we did in class was that we looked at what happens if you have the same volume of all of your objects. So like here you can see if we draw a line at the same volume for all the objects. Now if you take your line and you extend it over to the mass line, you would see that the wood would have a mass of that, water would have a mass that's much greater, and the domino would have a mass that's even greater than that. So you could use those relationships then to draw particle diagrams. So if we're talking about the same volume, which is what we did in class right here, we have the same volume of each of those objects. That would be like having a square the same size for each object. So here you can see we have squares which would represent the same volume of each of those objects. So now what we can do is we can put in our particles. And we did this in class, but this is just a little reminder for you. So let's say we're looking at wood. Wood would have a small amount of particles because wood has a small mass. So if we put wood, maybe we put 2 particles in the wood box. And if we look at water, water is going to have more particles because water has a greater mass. So we would have more particles in the waters box. And then if we look at dominoes, up here, dominoes have an even greater number of particles because dominoes have an even greater mass. So you would plunk more particles in the domino box. Okay, and so then this would show that dominoes have a greater mass in the same volume because we're talking about the same volume. All right, that was the idea that we were looking at here. They have the same volume. So let's talk about some conclusions that we came up with. Our conclusions were that when each substance has the same volume, the dominoes would have the most particles, like we just showed in our diagram right here. Okay, dominoes have the most particles. Oops. We would say that the wood particles show the most amount of empty space. Okay, you can go back and look at that. This is the wood particles right here. And the wood particles have the most amount of empty space. We said that the domino particle diagram has the least amount of empty space because the particles are packed tighter together. We said the steeper the line on the mass and volume graph, the greater the density. So when we're talking about how close the particles are packed together, we're talking about density. And we said you could find density by looking at the slope or the steepness. Think about running up a hill. We said density describes the closeness of the particles. Okay, so how tightly packed they are. And that is the amount of mass or the amount of particles in a given volume. The greater the density, the closer together the particles are. Okay, so let's just do a couple of little practice. First one here says draw a particle diagram showing two substances. A has a mass of 10 and a volume of 10. B has a mass of 5 and a volume of 10. So since they both have a volume of 10, they're both going to have the same size box for your particle diagrams. A has a mass of 10, B has a mass of 5. So B has a much smaller mass, so B would have a small amount of particles. A has a greater mass, twice the amount, so A is going to have twice the amount of particles. Okay, which one has the greater density? And the greater density, of course, would go to A. A has the greater density because its particles are packed closer together. So let's look at one more example. Draw a particle diagram showing two substances, A and B, with the same mass, but A has a larger density than B. So a couple of things you want to pick out here. Since they have the same mass, you know that they have to have the same number of particles. Okay, but since A has a larger density than B, that's a little bit different. Now, a bigger density means that the particles are closer together. So, without even drawing boxes, let's just draw numbers of particles. So if we want to have A have the particles closer together than B, let's just do this. So we'll do A right here. A's particles are close together. Okay. B, on the other hand, I'll just make it a different color to make it easy. B has the same number of particles. So B also has to have 6 particles like we just drew there. But since A's particles are closer together, B's must be farther apart. So B's particles, 4, 5, 6. There we go. So now they both have 6. So this would be how you would represent having the same mass but a difference in density. So that's all for now, and we'll see you.